Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're looking at lessons 2 and 3 in Unit 5, graphs of linear equations. And so we're just going to start talking about what those graphs of linear equations look like, some different forms that the equations can take. So we're going to start with a little bit of vocabulary. We have set of all solutions. And so when I say that something is the set of all solutions, that means that all values that can solve that equation, that's, as it says there, satisfy a given equation. So if you think about when we solve an equation for a line, or we have an equation for a line, that line continues on in both directions infinitely. And so the set of all values that satisfy that equation, we're talking about all of those points that would be on that line. And so we'll look at some graphs and talk about that concept a little bit more here as well. But so today we're going to look at two specific forms of linear equations. We have slope-intercept form, and hopefully that's not a new concept for you, something that you've at least touched on in prior math classes. But so slope-intercept form takes this form: y equals mx plus b. Y is our dependent variable. So when we talked about functions, we said that that was the output. And so y is that dependent variable or output. M is going to represent the slope or the rate of change of our function. We have x is our independent variable. I don't have that listed here, but x is our independent variable, would be our input when we're talking about a function. And then b represents the y-intercept. And your y-intercept is where that graph crosses the y-axis. You can also think of it as the value of the function when x equals 0. So if I plug in 0 for x, that's going to tell me, and then solve for y, that's going to tell me what that y-intercept value is. All right, so that's slope-intercept form. We'll take a look at some examples of that here in just a moment. The other form that we're going to look at is called standard form. And standard form takes this form: ax plus by equals c. And so we still have our x and our y, our independent variable, our dependent variable. But now instead of having something that's telling us slope and y-intercept, we just have some values a, b, and c here. The thing about a standard form equation is that we can very easily find both the x and the y-intercepts of a standard form equation. So we already said here that the y-intercept is the value of the function when x is 0. Well, the x-intercept is going to be the value of the function when y equals 0. And so by plugging in 0 for x in this equation, we would be able to find the y-intercept. If we plug in 0 for y in that equation, we would be able to find the x-intercept. And so we're going to look at that in these examples that we have here. So this first one asks us to graph the equation y equals negative 3x plus 2. And so this equation is in slope-intercept form. It takes that same form of y equals mx plus b. We have our y value. We have m in this case would be negative 3. Our slope is a slope of negative 3. We have our x, and then the value that's being added here would be our y-intercept. So our y-intercept is at positive 2. So if I was going to graph this equation, I would start by plotting that y-intercept. So when x is 0, y is 2. And then we could use that slope to create other points that would be on that line. I'm going to go ahead and pull up this equation in Desmos. So I've put the equation in, y equals negative 3x plus 2. And just going to use this graph to kind of illustrate how we could plot this if we needed to by hand. So our y-intercept is right there. There's our point 0, 2. So it's crossing the y-axis at 2. I'm going to zoom in just a little bit here. Oops, nope, zoom out. That's what I want. All right, so 0, 2 is our y-intercept. Now we have a slope of -3. That means that between points, any points on this line, there's going to be a slope of -3 or a rate of change of -3. And so you may have learned this as rise over run. If I'm looking at my graph to go from one point to another, if I go down 3 places and over 1, that's going to give me another point on that line. So 1, -1 would be another point. If I go up 3 places and to the left 1, that would give me another point on that line. Try and find the exact spot there. Should be at -1, 5. So that's another way that you can plot points using that slope. Negative slope here, -3. If we have a negative slope, that means that that line is going to decrease as we go from right to left. All right, let's take a look at the other example that we have here. And that's the second equation that is in standard form. So standard form is ax plus by equals c. So a would be 2, b would be 6, c would be 18. So those coefficients with the x or with the variables, and then our constant here. Now, if I wanted to graph this equation by hand, the easiest way for me to do that would be to find the x and the y-intercepts. And so we said y-intercepts the value of the function when x equals 0. So if I plug in 0 for x in that equation, well, notice 2 times 0, that's just 0. So that zeroes that term out, and I'm just left with 6y equals 18. And then to solve for y, I undo that multiplication by 6, divide it by 6, and y equals 3. So that means that my y-intercept is at 0, 3. I could do the same thing to find my x-intercept by plugging in 0 for y. So when I plug in 0 for y, notice 6 times 0 is just 0, so that zeroes that term out, and I'm just left with 2x equals 18. To solve for x, we undo that multiplication by 2 by dividing it by 2 on each side, and we get that x equals 9. And so when x is 9, y is 0. I now know my x and y intercepts, and so I could plot those 2 points and then draw the line in between them. I'm going to go ahead and pull this up in Desmos again. So we want to double check those points. So 0, 3, 9, 0. Here's my equation, 2x plus 6y equals 18. Oops, wrong way. We said the y-intercept is here at 0, 3, x-intercept at 9, 0. So if you were plotting this by hand, you'd plot those 2 points and then draw the line in between them. When we use that term, the set of all set of all solutions, when we use that term, this line represents the set of all solutions to that equation. So all of those x and y values that make that equation true fall on that line. All right, that's all I've got for you guys today. Appreciate you taking the time to watch the video. If you have questions, please let us know. Thanks. Have a great day.